So I want a couple more examples out of 11.6. So here are number 12 and 16. So starting with 12, I've got log of 5n minus 4 is 0. Okay, so how do I get the log out of there?
You're going to want to ring them.
Yeah, I'm going to want to put it in the power of something, right? And Alex, you just said what the base was. What's the base? 10, right? The standard log is base 10. So the log button on your calculator, remember, is a base 10 log. So I want to put everything in the power of a 10, right? So I've got 10 to the log of 5n minus 4 is 10 to the 0, right?
Wait, that's 1.
Oh, good. Awesome. Thank you. Right? I know that one. That was easy.
Yeah.
Okay, so now what do I do to both sides here? Wait.
Okay.
Oh, I can cancel the 10 and the log, right? Because those undo each other. That was why I did that, right? So what do I get on the left here? Yeah, 5n minus 4 is 1. And then
It's going to be 1, so you're going to add 4 and divide by 5.
add 4 to both sides, so we get 5n is 5. And then divide by 5 both sides. Get n is 1, right? You guys see that?
So can the zero product rule not work with any of these? Like how you just do 5n equals 0, it would have to be negative 4 equals 0?
So I don't have, I could subtract 1 from both sides. Then I'd have 5n minus 5 is 0, right? There's not a product there, so I can't apply the zero product rule. We could get there, actually. You want to see how that would work?
I guess so.
Okay, so alternatively, we could subtract 1 from both sides at this stage. So we'll get 5n minus 5 is 0. And then we could factor a 5 out. So we'd get 5 times n minus 1 is 0. And then we could use the zero product rule, because now I've got a product. Right? So my answers here are either 5 is 0. That one ain't happening. Or n minus 1 is 0.
Which is 1.
Which tells me n is 1. Okay, see that? I think that's probably a bit overkill for this problem. But it works. So don't feel like it's not going to work. All right, if we wanted to try 16, which says I've got the log of 5y minus 7 is the log of 2y plus 1.
Did you raise everything to the power of e?
Oh, very nice. We remember the base of the natural log is e, right? So we apply, put everything in the exponent of an e to both sides. So I get this funny looking thing, right? I get e to the log of 5y minus 7 is e to the log of 2y plus 1.
Now you take them out.
The e's and the natural logs cancel, right? So I get 5y minus 7 is 2y plus 1. Then what?
You solve for 1.
Yeah, I should solve for y. How do I solve for y? Okay, subtract 2y from both sides, so I get 3y minus 7 is
Plus 1.
1, right? Then I
That's 7.
add 7 to both sides, so I got 3y is 8.
8.
So y is,
8/3.
yeah, so there I'm dividing by 3, right? And I get y is 8/3.
Oh, what's the E about? I forgot that in that.
What's the e about? Yeah, remember, e is a number, right? A little bit like pi, right? We just picked a symbol to stand for a number. And the reason this one's special is that if we looked at the function, so all those exponential functions, they all go through this point 0, 1, right? And the ones with a base bigger than 1 all look like this. Right? They're kind of increasing. So there's one of those where this line here has slope 1. If I increase that base, it kind of gets steeper, right? So I can change that slope. The one with slope 1 is e to the x. This is just a way to define a number. The reason this is nice is this slope tells you something about rate of change, and it happens that having a rate of change of 1 and 0 is convenient for a number of reasons. This is a bit deep. There's a nice calculus definition for the number e. Until we have the calculus to make a good definition, we're just going to say it's a number and it's special for a reason that we don't have yet. Is that okay?